Hey everyone, and welcome to this explainer. Today, we are stepping into the incredibly fast-moving, high-stakes world of AI-assisted coding. Specifically, we're focusing on the Git observability behind a brand new platform called Entire. So, if you've ever had an AI agent write code for you, and then you just kind of stared at the screen wondering exactly how it arrived at that specific solution, well, you're in the right place. We are going to unpack the invisible mechanics that track, manage, and scale the massive volume of code being generated by AI agents today. Let's get into it.
Okay, let's take a quick look at our roadmap. We'll kick things off with the AI code provenance gap, then introduce the entire Git observability layer and look at how checkpoints actually capture AI context. After that, we'll see how shadow branches keep your history perfectly clean, explore scaling with distributed mirrors, and finally, we'll wrap up by looking at what this all means for a brand new developer assembly line.
All right, Section 1, the AI code provenance gap.
So here is the hook, and I know it's a question you've probably asked yourself at least once. Why on earth did the AI write this? You know, AI agents can crank out code incredibly fast, but the catch, they leave absolutely no trace of their reasoning once the session ends. The second that context window closes, the thought process basically just evaporates. You get the code, sure, but you completely lose the journey of how the agent got there. And that brings us to a crucial concept, the provenance gap. Simply put, this is the loss of reasoning, context, and intent behind AI-generated code. Imagine you're doing a code review, looking at a pull request generated by an agent. You can clearly see what changed. But without the provenance, meaning the history of the prompts, the tool calls, the iterations, you literally have no idea why the agent chose that specific architecture or logic. It creates a massive bottleneck when teams are trying to collaborate.
To put it in perspective, standard Git is absolutely phenomenal at tracking what changed, right? It gives us those beautiful line-by-line diffs. But it relies on humans to actually explain their reasoning in the commit messages, even if that message is just a rushed fix bug again. What we're dealing with now is the missing layer. For AI agents, we desperately need a system that tracks the why and the how behind their decisions directly alongside the code itself.
Moving on to Section 2, Entire, the Git observability layer.
Now this isn't just some pie-in-the-sky concept. There is serious momentum here. Entire just launched out of stealth mode with a massive $60 million seed round at a $300 million valuation. That is huge. And it's led by former GitHub CEO Thomas Dohmke, teaming up with veterans from GitHub and Atlassian. Honestly, that level of financial backing and sheer authority instantly tells you how critical and how big the problem they are tackling really is.
I love this quote from Thomas Dohmke because it totally grounds their vision. He says, "We must now reimagine the software development lifecycle for a world where machines are the primary producers of code." Basically, Entire isn't just bolting some AI gimmick onto our old human-centric workflows. No, they are building a platform from the ground up, specifically designed for this new era of agent-to-human collaboration.
All right, Section 3, checkpoints and capturing AI context. So how does it actually work? Well, Entire's first open-source product is a CLI tool that introduces a brand new Git primitive. They call it a checkpoint. When you fire up coding agents like Claude Code or Gemini, the Entire CLI automatically captures all this critical metadata in the background. We're talking the full transcripts, the exact prompts used, every tool call the agent made, and even the token usage. And the best part? The whole shebang is captured locally and safely right on your machine.
I want you to just take a second to let this sink in. Checkpoints essentially turn AI reasoning into a searchable, shareable, first-class version primitive. Instead of the AI's logic getting lost forever when you close your terminal window, it is permanently attached to your Git history, which means your teammates or even other AI agents can look at a piece of code and instantly pull up the exact conversation that produced it. It's a real game changer.
Let's look at Section 4. Shadow branches keep history clean.
Now you might be wondering, doesn't this bloat my repository with giant JSON files full of AI transcripts? Actually, scratch that. It doesn't at all. Entire built a really slick workflow. You just start your agent as normal. While it works, Entire tracks all those changes in the background on a temporary shadow branch. And since it's capturing snapshots, if your AI suddenly hallucinates and breaks everything, you can literally run a command to instantly rewind and restore your code to a known good state. Once you're finally happy with the code, you commit it, and Entire automatically tacks a tiny 12-character ID onto your commit message. That little 12-character ID, that's the magic link. Thanks to that, your primary Git history stays perfectly pristine. All that heavy AI metadata, the long transcripts, the prompts,
It all gets shunted away to a dedicated hidden branch called entire/checkpoints v1. So you get all this amazing observability on the web dashboard, but with zero bloat on your active working branch. Pretty clever, right?
Which brings us to Section 5, Scaling with Distributed Mirrors.
So, if we zoom out from the local Git mechanics on your laptop, what happens when you have, say, hundreds of agents running concurrently? Well, the reality is, centralized Git hosting completely fails for agents. Think about it. A human developer might clone a repo once a day, maybe push a few times. But agents, they are constantly cloning, fetching, and inspecting code at crazy high frequencies. When billions of agents hammer a single central server, it creates massive bottlenecks. We're talking strict rate limits, high latency, and sometimes even total platform outages.
To put that scale into perspective, get a load of these benchmark numbers for Entire's distributed Git network, which they call EntireDB. In testing, they sustained 570,000 clones per hour. They handled 1.7 million mixed clone and push operations, and a staggering 2.1 million pushes per hour. Obviously, these are not human numbers. This is the massive throughput required for the agentic era.
To pull this off, Entire built a fully decentralized Git network with regional mirrors. Right now, they've got them active in the US, the EU, and Australia. The cool part is you can keep your primary repository sitting right on GitHub, but set up a mirror on Entire specifically for your agents. Those agents then pull from the regional mirror. This gives them high concurrency, absolutely zero read rate limits, and, crucially for enterprise teams, it ensures sensitive code stays strictly within its designated geographical region to comply with data sovereignty laws.
Finally, Section 6, a new developer assembly line.
Bringing it all together, Thomas Dohmke uses a brilliant analogy here. He points out that just as the automotive industry shifted from a manual, craft-based production system to the moving assembly line, software development is making that exact same transition right now. Entire is basically providing the infrastructure for a modern, moving assembly line where humans and agents can seamlessly collaborate, hand off context, and ship software together.
And because they're capturing all this incredibly rich semantic data, they unlock some wildly advanced capabilities. Like, this is way beyond just simple Git hooks. Entire can actually track nested sessions, so if one agent spawns a sub-agent, it's all recorded. It calculates exact line attribution, meaning you know exactly what percentage of a file was written by an AI versus a human. There's a feature called Entire Blame to instantly see the AI's decision behind a specific line of code. You can even generate AI-powered summaries of past sessions to quickly get up to speed on the intent and any roadblocks the agent hit during development.
Which leaves us with this final, vital question to think about. As AI agents generate more and more of your code base, how will your team track the reasoning behind every single automated decision? Entire is making a big bet that capturing this context right next to the code isn't just a nice-to-have feature, it's going to be an absolute necessity for the future of software development. I hope this explainer shed some light on the Git observability behind Entire and the invisible mechanics of our new AI coding era. Keep learning, keep exploring, and we will catch you on the next one.